Hello, my friends of Hatari Labs. My name is Saul Montoya. Today we are going to talk about how to say a very interesting topic about this how to Pythonify. Modify and write with Python a pumping test model in MODFLOW. So this is something I have been working. You will receive with the description of this model, with the description of the video, a model that I have made. Let me delete this. And the model that I have made is this one, where you will have a Python file, and then this done in Jupyter Notebook, plus a model that will be, the model will be constructed based on a Python file. This is something interesting. Okay, for you, let's start Jupyter Notebook. Something about the history of this model. This model is actually for a web app that I want to. I want to put. Why I have done it with MODFLOW with Python is because I wanted to put it on a web app. So at the beginning I tried to use FlowPy, that is a Python library on MODFLOW. But to tell you the truth, it's an excellent software, and I will use it for to see the results. It's very handy. But somehow I feel that my perception is that the files were not, the options were hidden. MODFLOW is the MODFLOW software has a lot of options based on what you want to do or what you deal with the complexity of the groundwater model. And if you put this as a declarative way on the arguments on the command, it's like it's the user experience I am talking about. Maybe I'm wrong. And the user experience is kind of, there is a break on the user experience. Well, it's my opinion. Okay, so I was a little frustrated, so I did a model by my own. So I did a model that actually opens. You will see here. I don't know why Jupyter Notebook is so slow. Here I have this. I have the bus file, that is this is the bus file, is the file that defines the constant heads around. I don't know why the bus file exists if you can set us as constant head. What? Then is the constant head. This is the constant head file, and this is just to make, this model is just to make a pumping test. So here, and the model has it has 51 columns, 51 rows, and this will replace the 51 columns of 51 rows by this by the value of the nivel estático, that is the static level. And as well here, it will repeat it for the whole stress periods. As well as this discretization, this is more tricky. Since we have already the geometry determined, so I don't need I just needed to put it once, so this won't change. Okay, but however, the thickness of the aquifer will change depending on the because if a well is 40 meters, it has a depth of 40 meters, the script will apply the double of the depth as the model thickness. So that's why this will be replaced by the double. I mean, upon the model depth, it will replace the thickness as well. Okay, and it will repeat it for the whole. It will repeat for the whole years, for the whole other stress periods. Okay. What else do we have here? We have the num file. Very interesting. The num file is actually, it won't read this because this is not for, these are not ready for mod to be read on by MODFLOW. It will read what is created by the Python file. So those are the fixed. Those are here in fixed. These are the files written or modified by the Python file. Okay, what else do we have here? This MODFLOW NDVT, this is the only one that it is not. It's the only one that is not modified by the Python script, because it's actually it's only set the iterations and the discrepancies. And this is the observation hub. This is where the piezometric files enter, and it is created by the Python file. However, it is located. It activates where on the cell, on the well cell. I mean, on the cell where the well is located. Okay. Cool. And then we have observation control, and this is as well generated by the script. Okay. This is the upstream weighted. This is for the MODFLOW NDVT, and this is as well. This is written by the. This is written by the file, and as well this is written because this is almacenamiento específico, that is a specific storage for every layer is as well replaced here. So almacenamiento específico, rendimiento específico, that is a specific yield, and conductivity. Conductivity and hydraulic conductivity and vertical hydraulic conductivity. Okay, this is as well replaced by the Python file. This is observation concentration. No, no, this is up and on well. This is as well created by the Python file. Cool. What else? Nothing else. Okay. So what else do we have in this project? We close all of this. We have the Python file. What I will suggest, if you, in order that I really want that you play around and have like a great user experience, is please locate this exactly on your documents. Otherwise, it won't run, and you maybe, most of the errors that people write me is about routing. I mean, it's not, I mean, they say, oh, it doesn't run because actually Jupyter Notebook opens exactly what is on your documents, and you don't have the documents on your the file on your documents. So please, if you want to make this tutorial for you, I will suggest that you put this folder on your documents, and this will run. Okay. We have a model setup. .ipython notebook. I made a mistake, I think. Yes, I made a mistake because I set up a space, and the space is okay. I don't like spaces on my files because actually my Python and MODFLOW is really bad with the spaces, so I prefer not to use it. So if I want to use a space, I put something in between. Okay. Then I open. Okay. So, and this will open the model folder. So the model folder is this one. And these are the parameters of that needs the model. That is model. This is the static level, surface model top, well depth. This is the ratio between horizontal anisotropy, vertical conductivity, horizontal conductivity. This is the hydraulic conductivity. This is the specific storage and the specific yield. This is the pumping rate. These are the pumping schedule. It has to begin with 0 because at the beginning I can put something here, like I can put that I am pumping from the beginning. And something that is really fun is that this is actually in liters per second. Yeah. Usually MODFLOW do not allow you to change of units because you have to put it whether in meters or you have to put it whether in seconds. But this on the Python script actually make the correction, and these are the piezometric levels, and the levels are in meters above sea level. Okay. This open the bus file and as well replace the static level. Yeah, this opens the constant head file as well, replace it with the replace for the whole stress periods. Okay. Yeah. Okay. This opens the well file as well, replace it with the pumping wells, and look here that is negative because actually pumping on MODFLOW is negative. And it creates the pumping schedule, as well as here this is discretization that do the same. It creates the discretization, and here I have said something very interesting. The pumping and the recovery, each one has at least 10 stress time steps. Yeah, because you require a lot of time steps. However, if you, like, let's say if you have 5 pumping periods, like, it will apply 2 of them to, I mean, if you have 2 pumping periods, it will apply 5 time steps to every pumping period. If you have 7 pumping periods, it will apply 2 time steps to every pumping period. So you will end up on the pumping stage with 14. You will end up with 14 time steps. Yep. And for the recovery, you just have 10. Yep. Well, I set up that. For me, it's okay, but let's see. Okay. What else? What else? What else do we have here? We generate the pumping, the well text. This is the recovery. And then we apply it to the discretization file. This is for the observation control, as well is similar. And here we have for the op hop, this is for the observation for the piezometric data as well is similar. Okay, I have to clean something out, and this is for the to replace the hydraulic parameters, and this runs. So what I will do is that I will run. So I go to kernel, start and run all. Okay, and I run it. What is it took so long? Okay, so it's running, as you see. I don't know, maybe, I mean, if you run it on Linux, is or like pure Python, no? But to run pure Python on Windows is, I mean, if you are in Linux, it's almost organic how to use Python, but in Windows is you have to go through the back door of the software, and then you run. Okay, it has run, and it says that it's okay. And if I go to the Anaconda prompt, I see that it has run 1, 2, 3, 4, 5, 6, and this is the recovery. Okay, cool. And what else? Okay, so we have already run our MODFLOW model, and here on model we have, these are the fixed, these are all the files that were generated by the Python file, and as well here I have the results that are for example, the list file, and as well the observe value and the simulated equivalent of our pumping test for the whole readings. Okay, and what else I have here? I have on the list file, have the whole list file of the simulation. Look, and as well it appears here. Okay, so this is mostly what do we have on this script. I will be working in trying to. My intention is that this work with JSON. So I have to sort out how this will open a JSON file. What else? And here I have the observe simulated, but I wanted to as well to have the observation simulation, and as well I wanted to have the head for every cell in every step, because otherwise I will have few results. Okay, so that's something I wanted to do, and I know that this topic is very specific. Okay, something else. In order to prove that this is actually a MODFLOW model, I will open to ModelMuse. Okay, so I will open import MODFLOW next. I will open the num file. The num file, that is where you have it, documents, caso prueba bombeo model, and I open this num file. And what you have, where is it? Oops. Okay, cool. Here is our model, and you will have, I mean, everything that has a MODFLOW model. Okay, cool. Yep. And okay, and then here it's on model time. It has the whole time discretization. So cool, and it has the number of time steps. Cool. So I hope that you will find this useful, or at least funny, in order to that you can sort out how you can automatize, or like how can you do several runs or something like that with MODFLOW. And I hope to see you in another tutorial that we will have. We are from Hatari Labs. We have Hatari Labs, a website. Hatari Labs. Our main interest is knowledge sharing on free open source software in water resources. So, and then we have here a blog and some webinars, some coming webinars that you might be interested. Okay, so we have on Freaksy and so on. And we will promise that we'll have a lot of tutorials. So I hope that you can follow us, and then you can follow us by Facebook, and we have as well a newsletter, and so you can drop your email here, and then we will send you very nice and useful information on your email. Okay, great. Have a great day, and I hope to see you in another tutorial. Bye-bye.